How do superheated and saturated vapor differ in thermodynamics? Imagine a pot of boiling water. As it heats up, the steam rising from it is in a special state. Some of that vapor is just at the boiling point, while some is much hotter. That's where the difference between saturated and superheated vapor comes into play. Understanding this difference is key in thermodynamics, especially when working with phase changes and energy transfer. Saturated vapor is the state where vapor exists in equilibrium with its liquid from at a specific pressure and temperature. Think of it like a balance point. The vapor is holding just enough energy to stay vapor, but if you add more heat, it turns into liquid or becomes superheated. Its temperature is fixed at the saturation temperature for that pressure. For example, if water boils at 100 degrees Celsius at standard atmospheric pressure, the vapor at that point is saturated. It can be wet, containing tiny droplets of liquid, or dry, where all the liquid has turned into vapor but still at that same temperature. Superheated vapor is quite different. It has been heated beyond the saturation temperature at a given pressure. So, if the vapor temperature is higher than the boiling point for that pressure, it is superheated. It contains no liquid droplets and behaves more like an ideal gas. When you add heat to superheated vapor, its temperature rises further without any phase change. Think of it as a hot gas that's been heated past the boiling point, making it more energetic and less likely to condense back into liquid. One major difference is how temperature and pressure relate. Saturated vapor's temperature is directly tied to its pressure through the saturation curve. If you change the pressure, the saturation temperature changes accordingly. But superheated vapor's temperature is higher than the saturation temperature at the same pressure. So, at a given pressure, superheated vapor always has a higher temperature than saturated vapor. The phase state is also different. Saturated vapor coexists with liquid, meaning phase change can happen at constant temperature and pressure. Superheated vapor, however, is a single-phase gas with no liquid present. Its energy content, called enthalpy, is also different. Saturated vapor's enthalpy includes latent heat, the energy needed for phase change. Superheated vapor has more enthalpy because it contains additional sensible heat, which increases its temperature. Energy transfer mechanisms vary too. Saturated vapor mainly transfers heat through latent heat during condensation or vaporization. Superheated vapor transfers heat by increasing its temperature, similar to how a hot gas heats objects directly. This makes superheated vapor especially useful in power plants, where higher temperatures improve efficiency in turbines. Safety and stability are different as well. Saturated vapor is more stable because it exists at equilibrium conditions. Superheated vapor can be less stable and more dangerous if pressure or temperature suddenly changes, risking explosive conditions. That's why controlling superheated steam carefully is so important in industrial settings. In mechanical engineering, knowing whether to use saturated or superheated vapor depends on what you need. Saturated vapor is great for heating and drying processes where consistent temperature and latent heat transfer matter. Superheated vapor is preferred in steam turbines and power generation, where higher temperatures and pressures boost efficiency and work output. So, in simple terms, saturated vapor is at its boiling point, ready to condense or vaporize, while superheated vapor is hotter, with no liquid left, acting more like a high-energy gas. Recognizing these differences helps engineers design safer, more efficient systems involving steam and vapor.